Hello everyone, welcome to another session on Python for data science. Today we'll continue with Pandas, right? So yesterday, last session, we were just discussing different ways of joining multiple data frames. Today we'll look at a similar topic. We'll look at how do you combine multiple data frames, right? So basically, how do you concatenate different data frames? So that's what we'll look at. So we'll create three different. And you can just use the same above data frames only. So suppose say you have df1, right? You have df2. So you have df1 and df2. So what basically concatenation is? Concatenation idea is very similar. Okay, so you have two data frames. You either join row wise or you join column wise. Those are the two options which are available. So let's look at the first example where we'll join two data frames row wise. So row wise, what is the condition is it will basically look for the columns at what columns do you want to join. So let's look at the output of this. Maybe then it can be followed. The syntax is C again. Since you're running operation on two columns, basically you have multiple values, use a list, right? So we have been discussing this for quite some time now, right? So is equal to 0. So when you put taxes is equal to 0, data frame has no object. Okay, I think it's not written. Right, so you have data 1 and you have data 2. So in this, the problem is data 2 is you're getting NaN values. Why you're getting NaN values? Because data 2 column is not in the first data frame. Okay, so this is how do you concatenate rows. So axis is equal to 0 is row. Okay, again axis is equal to 0 is row. So look for rows and it will join. We'll get another example where we'll look column wise. Column wise, what does it look for? It looks for the indexes. Okay, so it is looking for the indexes. So whenever you have an index matching, it will input the values. If there is no index matching, it will be null or none. Right. So this is the output. Whenever you just combine, this is column wise concatenation. Okay, the other one was row wise concatenation. This is column wise concatenation. Okay, so fairly simple concepts. Just remember to use the parameter, axis parameter. Axis is equal to 0 will do row concatenation. Axis is equal to 1 does column concatenation. Okay, so next we'll move on to another topic, reshaping. So why do you need to use reshaping? Is so reshaping would be say converting normal data frames. Okay, converting row wise, converting long form data frames to wide form or wide form data frames to long form. So what is basically long form and wide form is? So long form is you have say it could be say you have a data frame wherein you have different these things. Say suppose you're trying to get the population of different countries. Okay, so what basically wide form, right? What basically a wide form could be, each column is a country name. Okay, each column is India, Pakistan, India, Pakistan, US, UK, Australia. So different column names, right? And corresponding values is obviously corresponding population values. This is wide form. Okay, long form is you basically have two columns. The first column is the country name, second column is the value. So basically all of your wide form data frame, right? So where you have more number of columns, it is converted into more number of rows, two columns. That is the difference. So you'll be actually using this a lot. So say if you want to visualize something, right? If you want to visualize something, it's preferred if you have a sort of wide, if you have a long data frame. Okay, so if you're actually trying to maybe model it, it is preferred if you have wide, simply because you have more number of columns, right? So we look at those. We look at two examples. So we'll just do again. We'll create a very sample data frame np dot random dot and then you're just creating a sample data frame, and you are having a index of list a b star 2. Then I'm just creating a very simple data frame. So what is the idea? What is the idea behind this is just want to see how do you basically convert your long form to wide form. So it's very common. You'll be doing this on a very common basis. So depending on your requirement, depending on the particular use case, it obviously varies. So this is one data frame. So you have a very sample data frame, X and a Y, A, B, A, C. So all of these are your indexes. You have two indexes over here. So let's just rename this to let's just rename this to different names. I got a 1 and I got a 2. So this is my DF. Fine. Next, we'll basically convert to a sort of a long form. See, you can understand this very simple terms. Wide, right? It is wide. Wide width, more width should be there. Correct. More width. Wide means more width. Correct. Long means more length. Right. Length. And this is length. This thing is length. The other thing is width. Right. Fairly simple to follow. Now, if you want to convert to long form, the function which you need to use is, say you're converting to long form. Long form is, so you have seen the data frame. Just look at the output. Things would become clearer. So df.stack. What df.stack? See, you can see those two values. I just put it in two columns. This is long form. Now we want to convert this back to your normal original format. The original format was your wide form, right? Unstack. So yeah, so df dot unstack. So I think instead of df dot unstack, it should have been lf dot unstack. You get your original values, right? So this is basically how do you vary from your long form to wide form to long form. Okay. So one more important this thing is something called pivot tables. Okay, so pivot tables are also commonly used. So what are pivot tables? Pivot tables, it's like groups. So you want to create your grouping by rows and your grouping by columns as well. Okay. So you are grouping by rows and you are grouping by columns also. So after grouping after grouping by rows as well as after grouping by columns, basically you basically get aggregate values. That's also it's a very useful tool. So it's very useful tool for getting summary of the data at different cuts. So for folks who have actually worked on it or from an Excel background, definitely know how useful is it. So in a very similar manner as you do it in Excel, right? Pandas basically has a functionality for that as well. It basically has a functionality similar to pivot tables, where you basically put a filter on your rows. Obviously, it won't be dynamic as you've seen in Excel, but the idea is similar. So you basically aggregate basis of rows, aggregate on the basis of columns, right, and get your value. In a very similar manner, Pandas has functionality. It's called pivot tables. I think it's called pivot tables. Even the name is along similar lines. Basically, what I'm trying to create is trying to create 3 columns, wherein it would make easier to follow. Okay, so looks like there is a mistake somewhere. Okay, so np.random.rand n. So I got this. Okay, looks like there is a mistake. I think I know where the mistake is. So this is a mistake. So this should be. Yeah, I think now it should be fine. So it's fine now. So we just have a df. So you have a date column, item column, status column. Now, what is so whenever you run df.pivot, so there are two functions actually. The first function is pivot. First method is df.pivot. The second this thing is df.pivot underscore table. Okay, so df.pivot. So this will give you this thing. Index column data pivot table. So this is like a long pivot. We'll look at what is the difference between these two. Difference between pivot method as well as pivot underscore table method. So first is specify the index row, right? So basically, what do you want to aggregate row wise, right? So next, what do you want to aggregate? Column. What are the column names? Next, you specify the value. What is the value? Right. So the value is the status column. So you are basically aggregating row, aggregating column, and you're getting the value. Right. Now this is df.pivot. Right. Again, so very similar to your Excel based this thing. So, but the problem is, I think it's applying mean over there. You can have a look at the. So what is aggregation value, right? I think the aggregated value is it by default it takes the mean. Right now, say suppose you want to apply some other function. That is where the pivot table this thing comes into the picture. So you specify index, you specify columns. Okay, so you want item. You want item. You want values. You want values. Now this is where you need to specify the aggregate function. So pivot underscore table you'll have control over what I will say. So as you can see, when you type mean, you'll get the same output. So it is applying mean over there. You can apply any sort of functions you want, not a problem. And count. Yeah, it's taking the count. So you can apply any sort of functions. You can write your own custom functions. There are a whole lot of other ways to make improvements, make changes to it. Okay. That's it, guys. Thank you for joining this Pandas session. We'll again meet in the next session. Thank you, guys.